8th graders. Some of you did a great job attacking the solving systems of equations part 2. I had just asked you guys to each take a problem and just try it. Some of you did the first couple problems and did a pretty good job. There might have been a couple errors here and there. Some of you tackled some of the harder problems and were able to do that. So hopefully that means that you guys are really having a good understanding of what we're doing here with substitution, what we're trying to accomplish, and following all those rules that come from solving different equations. So I'm going to start with the first examples here. Now it says, what if both equations have a variable isolated? No problem. So I'm going to show you a numerical example first. So if I said y equals 6 plus 4 and y equals 5 plus 5, would you guys be okay if I wrote 6 plus 4 equals 5 plus 5? Well, I hope so, because 6 plus 4 is 10 and 5 plus 5 is 10, so that's true. So what you're going to do when you have both sides or both equations isolated for the same variable, what you're going to do is you're going to replace, you basically set them equal to each other, because this is going to go in for there. We're not inserting it for like the x in the equation like we were kind of doing before, because the y is the one that we have solved. So this is going to go right in there. So your new equation is going to read negative 2x equals, and then you're going to put this in there, negative 8x minus 36. Okay. So then you have to solve the equation. So your line kind of goes down the middle there. And to solve, we're going to move the 8x to the other side by addition. This cancels. You get 6x equals negative 36. Divide both sides by 6. X equals negative 6. And then what we're going to do is we're going to take this negative 6 and we're going to put it back in to the other equation. So then we would have y equals negative 2 times negative 6, y equals positive 12. So if you solve this one on your own and you had the solution negative 6, positive 12, you did it right. Great job. Okay. The next one, we are going to set them equal to each other. You can think of putting this in here. So my equation is going to read x plus 10 equals 10x minus 8. Now in this one, when you have two sides of the equation, we have variables on both sides, so I like to play weakest link. So who's weaker, x or 10x? And that's why I would move the 1x to the other side. So this gives me 10 equals 9x minus 8. And then I would add the 8 to the other side. And I get 18 equals 9x. Divide both sides by 9. 2 equals x. So when you have your x, you can go ahead and put that number back in to that top equation. So I have y equals 2 plus 10. Y equals 12. So your second answer is 2 for your x and 12 for your y. You don't always solve for the y first. That's just how it happened, or your x first. That's just how these two were set up. They were both in slope-intercept form. They had a really good question. They said, can you tell what the answer is before you solve it? You can't necessarily tell what the answer is, but you can tell if this is going to be a special case. So because these were both in slope-intercept form and they both had different slopes, I know they're going to cross someplace. So if you were going to have a special case, you'd probably be able to pick it out if they were both in slope-intercept form. Okay, so the next two systems address a common mistake. What do you think it is? And I can look at it and I know what it is. And the reason I know what it is because when I look at this, I have y by itself. So I know I want to put this in, but I'm going to put it in right here. What's in front of that y? A negative. And so if that negative is there, you guys are kind of going to be more likely to make an error with that problem. So what I'm going to do is I am going to write my problem negative 7x minus, but I am going to put the 3x minus 16. And there was one of you guys that did this problem and you did it perfectly. So I was really excited to see that you didn't forget distributing that negative. This has to go to both of those. So this goes negative 7x minus 3x plus 16 equals negative 24. Combine your like terms. Negative 7 minus 3 gives you a negative 10x plus 16 equals 24, negative 24. And you subtract 16 from both sides. Negative 10x equals negative 40. Then your last step is to divide both by a negative 10. X equals positive 4. So then you're going to put this into the simpler of the two equations, that bottom one. So y equals 3x minus 16. Y equals 3 times 4 minus 16. Y equals 3 times 4 is 12. 12 minus 16, negative 4. So your answer, your solution is 4, negative 4. Okay. Next problem, you're going to throw this in for y. Again, you've got that negative in front of that variable, so you want to make sure you're not forgetting to distribute that. Okay. The first, negative 7x, positive 21. Oh, I almost thought I was making a mistake because it's so similar to the other one. Then I have negative 10x minus 21. You divide both by that negative 10. It is so similar to that other problem. X equals 4. You put it back into that original equation. Got y equals 7x minus 21. Y equals 7 times 4 minus 21. 7 times 4 is 28 minus 21. Y equals 7. So your solution is 4, 7. Okay, so the next two problems, why they are more difficult is because you don't have a variable that's isolated. But here's the thing, every time you look at a problem, there's probably going to be one of the 4 that are easier to get by itself. So what I do is I kind of just go through, what would it take to get x or y by itself, x or y? Well, which one's the easiest to get by itself? And that's definitely this x. And over here, the same type of thing, which of the 4 would be easiest to get by itself? It's definitely that y. So those are the ones that I'm going to start with, and that's what I'm going to do first. Because in order to solve with substitution, you have to have a variable by itself. So in this one, I would add 5y to both sides, and I get x equals 12 plus 5y. So now I can take and I can put this in one mistake. You can't put it back into the equation you just changed. You have to put it in for x in the other equation. So just be careful of that. So this is going to go in right here. So 3 times 12 plus 5y plus 7y equals 14. And then this would give me 36 plus 15y plus 7y equals 14. I can add my y's together. 15 and 7 gives me 22. And then I'm going to move this 36 to the other side. When I subtract, I get 22y equals negative 22. Then when I divide both sides by 22, my y equals negative 1. Okay, and then when I get my y, I'm going to put it back into my y in my equation that I have x by itself. So x equals 12 plus 5y. X equals 12 plus 5 times negative 1. X equals 12 minus 5. X equals 7. So 7, negative 1. Make sure you write the x before the y. Okay, next problem. To get y by itself here, I would add the 4x to the other side. So this equation is going to look like y equals 1 plus 4x. So then this is going to go in for y. So your equation reads negative 3x, plus 5 times 1 plus 4x equals 5. Negative 3x plus 5, remember you're distributing, plus 20x equals 5. 3x and 20x, they're on the same team, so you can, or they're on the same side, so you can add them. So I get, or subtract them in this case, actually. And then I subtract 5 from both sides. 17x equals 0. Divide both sides by 17. X equals 0 divided by 17 is 0. So this is going to go back into this equation up here. Y equals 1 plus 4x. Y equals 1 plus 4 times 0. Y equals just 1. So your solution is 0, 1. Okay, so those are some areas of common mistakes. We've got just a couple more problems. Same type of situation here with these two. They are only more difficult because the variable isn't by itself. So on the first one here, this side, the variable that I'd want to get by itself, would be this one. Okay, and then on the second one, it would be this x, even though it has a negative with it. Okay, so here I am going to subtract the 7x. Now I will tell you this, it's tricky because I could do this problem 4 different ways. I could technically get the other variables by themselves, they're just not going to be as pretty. And we like simple, we like nice and neat, so you avoid messy situations. That crosses that out. So that's why we always try to work with a variable that's by itself. That is going to go in for y right there. So my problem, negative 14x minus 2 times negative 6 minus 7x equals 12. negative 14x. When you distribute the 2, it has a negative with it, so it's a plus 12 plus 14x equals 12. Okay. So combining like terms, negative 14 and positive 14, they zero out. Well, you have 12 equals 12. What happens when you have 12 equals 12? That is a true statement, remember. So it's one of our special cases. It's infinitely many solutions. So sometimes we're still going to run into those types of problems when you're solving them, as you should expect. Okay, the next one. I have negative x minus 2y equals negative 11. So I told you that I was going to try to get that x by itself. So the first thing I'm going to do is I'm going to add the 2y to the other side. You guys are really good at working these equations to get certain variables by themselves. Okay, now my next step, I'm going to divide by that negative 1. Just remember, you have to divide everything by that negative 1. So it turns into x equals 11 minus 2y. So this is going to go into the other equation for x. And these are the ones that kind of get a little bit confusing. So now what I'm going to do is I'm going to take that 6x equation, negative 6 times 11 minus 2y minus 4y equals negative 10. Distribute, negative 66 plus 12y minus 4y equals negative 10. Okay, so when I do this, I get negative 66 plus 8y equals negative 10. And then I have to get the y by itself, so I'm going to add the 66 to both sides. 8y equals, and then this gives me 56. So divide both sides by 8, and my y gives you 7. Okay, so then I'm going to take, and I can put this y just right over here into this equation. So I have x equals 11 minus 2 times 7. X equals 11 minus 14, so my x equals negative 3. So my two answers are negative 3 and positive 7. Okay. So the last system does not have any easy variable to isolate. Okay, we don't really like these, but next you're going to learn a little bit more to help you with this. So substitution would not be the best method to choose to solve it algebraically. However, if that's the only algebraic method you know right now, you just have to do it. Okay, so what I do when I do these problems is I try to pick like the least, of the evils. So you just try to pick one of the variables to get by itself. So for example, in this one, I am probably just going to pick to get x by itself, and the reason is because dividing by 2 is going to be not too bad, whereas if I divided by 3 or a 7, the 16 is not going to be nice no matter what I do. So I'm going to take that top equation, that negative 2x plus 5y equals negative 12, and I am going to get the x alone. Okay, so this means that I'm going to minus 5y from both sides. You get negative 2x equals negative 12 minus 5y. Then I'm going to divide everything by a negative 2. This also changes everything to positive, which we kind of like. Excuse me. So x equals 6 plus 5 halves y. Okay, So this is what's going to go in for x in the bottom equation. Remember, you have to put it into the other equation. So this equation was right there. Okay, so now my bottom equation, I have negative 3 times x, but instead of x, I'm going to put in this 6 plus 5 halves y plus 7y equals negative 16. And distribute this, negative 18 plus, I'm just going to put this as 3 over 1 in my head there, so this gives me a negative 15 over 2. You could use the calculator. 15 over 2, I know is 17 or 7.5. So I'm going to add those together. It's a negative 7.5 and a positive 7. So that gives me a negative half. You could have 0.5 if you'd like. Doesn't matter to me what you do. I'm going to add the 18 to both sides. I get negative 0.5y equals 2. Divide both sides by a 0.5. You end up with y equals negative 4. So you end up getting a decent number. It's not like you can't do it. So then the third part is you're going to put this back in for y. So if your equation reads x equals 6 plus 5 halves y, so you've got too many things in my hand, x equals 6 plus 5 halves times negative 4. 5 halves times negative 4 is negative 20 over 2. 20 over 2 is negative 10. So you end up getting a negative 4. So your solution is negative 4, negative 4. They're both negative 4s. Okay, last problem. Oh my goodness, this video is getting long. Last problem, word problems. It says to solve, let's create a system of equations and use substitution. So it says to see the school play, it costs $4 for a regular ticket and $2 for seniors. Last night the school sold 100 tickets and made $310. How many regular tickets did they sell and how many seniors did they sell? So these problems, if you can just try to break them down into what are the two variables. So the two variables are the number of regular tickets and the number of senior tickets. So I'm going to have x be number of regular and y be the number of senior. Okay, so we know that they sold 100 tickets total. So the regular tickets plus the senior tickets would give you 100 tickets. So that's one of the parameters. The other thing is we know the total ended up being $310. So we can take $4 for a regular ticket plus $2 for senior tickets would equal $310. So now we're going to solve using substitution. Well, you have to get x or y by itself. Does not matter which one. So let's just change this one. So I'm going to move the x over. So I have y equals 100 minus x. Okay, and then this is going to go in for y. We have 4x plus 2 times, I'm going to put this in 100 minus x equals 310. So 4x plus 200 minus 2x equals 310. 4x minus 2x, 2x plus 200. Then I'm going to move that 200 to the other side. 2x equals 110. And then if you divide both sides by 2, my x equals 55. Well, what was x? So writing this down is sometimes kind of helpful because you're like, oh, well, x is regular tickets. So they sold 55 regular tickets. Now, in this case, if they sold 55 regular, you put it in right here if you want. Y equals 100 minus 55. So if they sold 55 regular, they sold 45 senior citizen. There was only, believe it or not, there's only one answer to this problem, okay? So, to make exactly $310, they had to sell 55 regular and 45 senior citizen tickets. Okay, so I hope this was helpful. You guys are going to do the homework, and then that iExcel, if you had any trouble with it, you should be able to do it now because we've done the hardest types of the problems. Good luck. We'll talk to you later.